Today on the BV3D channel, I might have to admit something. In a previous video, I showed you how to design screw holes for non-self-tapping screws, that is, machine screws, using a truncated cone in Tinkercad. It worked great, but a bunch of you left comments saying, "Brian, why not just use self-tapping screws?" And you know what? That's a fair point. So today we're going to find out if I over-engineered something that didn't really need to be all that complicated. And we'll get started right after this. This video is sponsored by PCBWay. Hi, welcome back. Okay, so if you missed that earlier video, here's the short version. I had a bunch of machine screws, you know, the kind that don't cut their own threads. They're great for screwing into tapped holes in metal or into nuts, but in plastic they can be kind of frustrating. You need the hole to be just right. If it's too small, you can't get the screw started, and if it's too big, it strips the plastic, or worse, the screw just spins. So I came up with a way to make screw holes that work with that kind of screw, even though they aren't self-tapping. The idea was to use a truncated cone in Tinkercad, basically a cylinder that's slightly wider at the opening and narrower at the bottom. That taper means the screw finds its own perfect grip somewhere along the hole. It worked beautifully, and I still think it's a neat trick, but it might not have been the most practical solution, and that's where all of you came in. After that video went up, a bunch of you pointed out the obvious. You're using the wrong kind of screw. And honestly, you were right. I was trying to make the screws that I already had work instead of just using screws designed for the job. So this time we're going to look at the right screws, self-tapping screws, and see just how much easier they make things. Self-tapping screws are designed to do what my truncated cone trick was trying to help with. They cut their own threads. These are often called plastic screws or thread-forming screws, and you can find them all over Amazon. I'll put a link to a few sets in the description. The sharp edges on the screws' threads actually cut into the plastic as you drive them in, and the tips of the screws are tapered. That means you don't have to worry about thread pitch or friction fit or tapered holes. You just make a straight-up cylindrical hole and let the screw handle the rest. And the best part? They're cheap. I picked up this assortment of self-tapping screws, 500 pieces in sizes ranging from M3x6 up to M3x20 for about 12 bucks. That's a ton of screws in a bunch of different lengths for about what a cheeseburger, fries, and a Coke cost these days. So to test this out, I made a few simple parts in Tinkercad. Nothing fancy, just a small rectangular block with holes of different diameters. Because if these screws are going to tap their own threads, I shouldn't need to design anything fancy. No cones, no tapers, no clever geometry, just straight holes. So I made a block with several different through holes. For these M3 self-tapping screws, I made holes in 0.1 millimeter increments from 2.6 millimeters up to 3.0 millimeters to see which one grips best. Before we test these, let's make a prediction. I'm expecting the 2.6 millimeter hole to be too tight and the 3.0 millimeter hole to be way too loose with maybe a sweet spot somewhere in between. But what do you think? Drop a comment right now with your guess. Which hole size do you think will fit best? No scrolling ahead. We'll see if you're right in a minute. All right, let's print these out and see what really happens. I printed the test blocks in PLA with 0.2 millimeter layer height, 4 perimeters, and 15% infill. I know we're just testing hole fit and not part strength, but this test piece is quick to print, and so it doesn't hurt to have 4 perimeters for strength. Now, before we start testing, a quick thank you to this video sponsor, PCBWay. PCBWay is known for making low-cost, high-quality printed circuit boards, but they also do CNC machining, 3D printing, sheet metal fabrication, and even injection molding. They sent me a few samples, and I gotta say, these circuit board rulers and coasters are freaking amazing. And the clear resin prints of the PCBWay logo, these are 100% crystal clear. So whether you need PCBs, machining services, or even something printed in a specialty material your printer can't handle, PCBWay can do that for you. Check them out at PCBWay.com. Okay, let's get back to it and see how these self-tapping screws actually perform. Let's start with the 2.6 millimeter hole. That one's pretty tight. I can get the screw in, but it takes a bit of pressure to turn. Once it bites though, it starts to cut threads. So it's tight, but it works. If you're using 3 or 4 walls or perimeters, that'll hold tight, but in thinner parts, that might risk cracking. Next, the 2.7mm hole. Honestly, this one seems about the same. The screw starts cleanly and it happily cuts its threads into the plastic. But there's still a good amount of resistance to get this to turn. Now, the 2.8mm hole. This one might be the sweet spot. The screw goes in more easily and I can still feel it cutting threads the whole way down. Solid grip, smooth start, and hopefully no risk of splitting on thinner parts. In the 2.9mm hole, the screw starts easily as well. I'd say it's easier to turn too, but I suspect it doesn't have as much plastic to cut threads into. That said, I'm able to snug it down and it doesn't feel like it's going to strip the threads. And at 3.0mm, the screw is easier to turn than the 2.9mm hole. I mean, there's still friction, it's still cutting threads, and I can snug it down, but I'd be afraid of accidentally over-tightening it and stripping out the threads. So that's actually pretty interesting. I was anticipating a different result than what I actually got. So what was your guess? Like I said a minute ago, I expected the 2.6mm hole to be too tight and the 3.0mm hole to just spin. But what I actually found is that with self-tapping screws, they're incredibly forgiving when it comes to hole sizing. I'm actually kind of shocked to see that these screws worked this well with this much variability in the hole sizes that I tested. If you're designing your own parts, though, I'd recommend undersizing the hole by 0.2 or 0.3mm compared to the screw's outer diameter, at least for little screws like these M3 ones. The product page for these didn't have information about the minor diameter of the screws. That's the diameter of the screw shaft that the threads are attached to. But if you have that available, that should probably be your target for your hole diameter. If in doubt, make and print a test part like I did to ensure you get a good fit with the screws you've got. And that's really all there is to it. So after seeing how forgiving these self-tapping screws are, I've got to say this really puts that truncated cone method into perspective. That cone trick I came up with still works great, especially if you've got a stash of machine screws like I do. It lets those screws grip plastic without inserts or nuts, and it's still a clever way to use the hardware you already have. But these self-tapping screws, they don't care a whole lot about perfect sizing. Sorry, I had to. They'll cut their own threads across a surprisingly wide range of hole sizes and still hold. So all that trial and error, making, printing, testing, is mostly unnecessary if you just start with the right kind of screw. For me, that's the big takeaway. The truncated cone idea is great when you need it, but if you're designing new parts from scratch, the simpler approach wins. Sometimes the best way isn't the cleverest, it's just using the right tool for the job. So was I wrong about screw holes? Well, not really, but I definitely learned something new. The truncated cone idea still has its place. If you've got a bunch of machine screws lying around and you want to make them work in plastic, that trick still works great. It gives you a nice friction fit without inserts or nuts, and it's still a clever solution when you need it. But self-tapping screws? They're just easier. They don't need fancy geometry, they don't need much trial and error, and they work across a wide range of hole sizes. They're the definition of forgiving. So if you're designing a new part and you can choose your hardware, skip the tinkering, grab some self-tappers, and call it a day. Sometimes the smartest design isn't the most complicated one, it's the one that saves you time, effort, and a whole lot of frustration. If you've got a favorite type or size of self-tapping screw for 3D printed parts, drop it in the comments. I'd love to hear what you're using. Thanks to everyone who left those comments on the truncated cone video. Seriously, that feedback helped me to make this one. Thank you for watching, thanks to PCBWay for sponsoring this video, and big thanks to everyone who supports the channel, whether with channel memberships or by using the links in the description. If you liked this one, give it a thumbs up and maybe subscribe so you don't miss new ones. Well, 3D printing friends, that's about all the time we have for this one, and now that we're at the end, let's go print something cool.